Hello again, this is Mukesh and you're watching STEM tutorials on MicroSchool.
Hello and welcome to the second video tutorial for Arduino TinkerCAD. In the previous video, we looked at TinkerCAD, which is an online platform for building circuits and simulating them. We did mention about programmable electronics like Arduino. In this video, we shall look at them. We will also look at various Arduino boards and the software application required to program these boards. Finally, as an example, we will also look at the program to blink an onboard LED. To learn more about Arduino, you can visit their webpage arduino.cc. There's a lot of learning material and documentation available on Arduino. Arduino is an open source hardware prototyping platform. Open source means that all the design data related to Arduino board and the software is available for creating your own custom version. For its simplicity and ease of development, Arduino has been very popular among hobbyists, makers, and professionals for quick prototyping of their design concepts. Arduino comes in a variety of form factors. There is variety of Arduino boards based on compute power, clock speed, number of input and outputs, and other parameters. For example, this is a family of Nano boards. Then there is a family of MKR boards. Then we have the classic Uno family. We shall be looking at Arduino Uno Rev 3 boards for this tutorial. To program our Arduino board, we need to create a code and download it. To do so, Arduino software can be used. So if you click on the software tab, it takes you to the Arduino software download page. And this is how it looks. Now let us use the TinkerCAD to build Arduino circuit and create a sample program. So here we are. This is a circuit we built in the last video. Now what we are going to do is create Arduino Uno based circuit. To do so, you can drag the Arduino board from the library and drop it on the workspace. I will get rid of the other components because we don't need them. As we now have the programmable component, that is our Arduino board, we can look at the code. So if you click on the code, now you can program this Arduino board in three different ways. One is by creating a program using graphical blocks. This is jigsaw puzzle-like blocks. You can drag and drop into the code area. You can combine them and make a program. If you noticed, on Arduino software, there are two key functions, setup and loop. Setup function is where you put all the codes which runs only once the Arduino board is turned on or powered on. And after executing the code or the commands within the setup function, it comes to the loop, and the loop function gets executed from top to bottom, and it continues forever until the Arduino board is powered down or reset. The same thing is graphically represented here with the two functions on start, which is equivalent to setup, and forever is loop. If you are new to text-based programming, for example, Arduino C, you might want to go to block and text, where you still do the program using graphical blocks, but equivalent Arduino C code is generated from those graphical programs. For advanced users who are well versed with the text-based programming or the Arduino C, you can directly go to the text-based programming, so the option 3, and you would be able to see the same structure as we saw on Arduino software, setup function and the loop function. By default, the sample program loaded here is to blink the onboard LED, which is marked here as L. Now this LED can be blinked. It means it can be turned on and off in a loop. And if you look at the code, you would see in the first instruction, which is under the setup, which executed only once, is pin mode LED built-in output. What it means is we are configuring the LED built-in pin, which is pin number 13, connected to this LED as an output. And then in the forever loop, we are turning it on by or setting this pin high and then waiting for 1000 milliseconds, which is 1 second. Then turning it off by setting the pin low and then again waiting for 1000 millisecond or 1 second. It means the LED is going to be on for 1 second, then off for 1 second, and it will continue. So let's see whether it works or not. So we got the circuit, we have the code, and now what we do is simulate. Once we simulate this, you should see the LED blinking, the onboard LED, which is connected to pin number 13. There's also a simulator time. It means this is simulating the time since the start of Arduino. For a simple circuit or less complex programs, this could be very much similar to your system clock or the computer clock. But if you have a complex program that takes long time and effort, long compute power to get executed, the simulator time would be very slow compared to the original or to the real-time clock on your computer. Now, if you want to make changes to the code, for example, if you want to make it on for just 100 milliseconds and keep it off for say 2 seconds, we can change the parameters. So I changed the parameter, which is 100 millisecond, and the off time for 2000 milliseconds. And if I start the simulation again, you would see it turns on only for a small period, but stays off for a longer period, that is 2 seconds. So anytime you want to make change in the code, you can stop the simulation, make changes, and when you're satisfied, you can again start the simulation. That's all for this video tutorial. In this video, we looked at Arduino, different variants of Arduino boards. We picked up Arduino Uno Rev 3 board for our programming tutorial. And we also looked at the blinking code. And here comes the programming challenge. You need to use two LEDs, two external LEDs, red and blue, and blink them alternately by programming the Arduino board. Drive the LEDs through Arduino board, say pin number 13 and 12, for example, and make sure that when one LED is on, the other should be off. Blink the LEDs like you did for the single onboard LED. You can post your answers as comment to this video. Hey guys, I hope you liked the video. Don't forget to like, subscribe, and press the bell icon to stay updated with our video tutorials. Bye bye.